So the first part of 6.2 is looking at some things that we need to talk about before we can actually make the predictions. Line of best fit, extrapolation, things that just are basic knowledge that you need to know that you're controlling before you go on and make your predictions. Now this video, we're going to be looking at one of the two ways of making predictions. Okay? The two ways of making predictions, we have the line of best fit, where we're just basically an eyeball estimate. Drawing our line of best fit and we're looking at what the line's showing us. The second is the equation for the line of best fit, the regression equation. That's using the algebra for the line of best fit, and we're going to use that equation to make our predictions. Okay? So first, we're going to use the line of best fit. The question is, what is the median household income if the mean income per person is $30,000? Okay, so the first thing we need to do is actually draw the line of best fit. So let's see how good we can do. Again, I'm expecting yours to be a little nicer. You should have a ruler. Draw it once, pull it away, see if you like it or not, maybe erase it, do it again. This one I'm going to say is good enough for what we're doing, just the examples. Okay, probably have a couple more points above, but we have some outliers that might have pulled our line of best fit down. Now the question is, what is our household income when the income per person is $30,000? There is a little bit of work I want to see here. I know I said it's an eyeball estimate, but I want to see where are you getting your estimate from. So I want to see, okay, there's $30,000 for the per person, mean income per person. And I want to see the line going up and then over, okay? And again, you guys have rulers and things, so yours line should be a little nicer, okay? And that's showing me, okay, I went up from 30 to the line of best fit, and over for the median household income. Okay, so we can see that's probably about just under $45,000. Now these are an estimate, so I expect to see the language of estimation. So if I put this, I'm going to say just below 45,000. Okay, don't try and look at it and say, okay, it's $44,558. Okay, we're not getting that detailed with it. But use that language, just above, right around, just below. Okay, these in between even would be good. So we're about 45,000, just below 45,000. Okay, here we're looking at CDs sold and cassettes sold. These are both in millions, so also make sure you pay attention to the units when you're making these predictions. How many cassettes are sold? When 700 CDs are sold. Okay, let's actually say 700 million CDs. Sorry, that's a typo on my fault. 700 million CDs are sold. Okay, so again, I'm going to draw my line of best fit. Okay, so there's our line of best fit, or again, as good as I can do up here on the board. And I'm going to go to 700 million, up, and over. And you're going to the line, not a point. Some people will stop if they hit a point first. Make sure you go up to the line and then over. Now this is just under 300 million cassettes, so that's what I'm going to say, just under 300 million cassettes. Okay, so again, language of estimation, I'm showing my lines up and over to show how I'm making my estimate and how I'm coming up with my estimate. And let's get one more example here. Okay. Now this is looking at the baseball game, stolen bases per game, and we're also looking at the runs per game. Now if I'm looking at my line of best fit for this one, okay, I'm going to say my line of best fit, probably something like that. It's not exactly the best line of best fit, it's a horizontal line. So let's investigate a little, let's see what happens. How many runs will be scored when one base are stolen in a game by one team? So what I'm looking at here is one base stolen, how many runs are they going to score? So I'm going to go up and over, but look what happens. Up. My line going across is basically on top of my line of best fit. Okay, so we're between 4 and 5 runs here. So we're estimating between 4 and 5 runs. If I would change this problem though, say if I change it to half a stolen base per game, well, we're going to get the same result over and over again. No matter what this value is, With a horizontal line of best fit, it's not going to change. You need to have some kind of slope to be using the line of best fit, okay? You can't have this slope, the horizontal line slope, okay? This slope of 0 is not going to work, okay? If we were writing this equation, we would have y equals 4.5. So no matter what x value we plug in, our y is going to equal 4.5. Okay, so you need to have some kind of slope to make this line of best fit a useful way of making predictions. Okay, with not, you'd have to find another variable. Stolen bases per game really has nothing to do with how many runs are going to be scored per game. Okay, so that's your line of best fit, or at least using your line of best fit to make predictions. Next video is going to have to do with the regression equation. How to find it using your calculator function, how to make predictions with it, and using that equation to interpret what the slope and the y-intercept mean to our situation.